Now we turn our attention to a system of 3 linear equations with 3 variables, and then consequently when we do that we increase the dimension from 2 dimensions to 3 dimensions. So what changes here? Well, a lot and nothing at the same time. So geometrically we no longer have lines. When we look at equation in 3 variables, oops, let me highlight that instead. That equation represents a plane, okay? And planes can intersect in a variety of ways. So here are the different types of intersections that we can see. Here in the very left one, this is actually a single point. So that would just be like x, y, z, whatever those values are of x, y, and z. And kind of this next one, the idea is if we need to satisfy all 3 planes simultaneously, are they satisfied? Well, in this one, no. In this one, no, because they're kind of parallel planes. And then this last one, this would mean like, and you can just barely make it out, but 2 planes are effectively the same. They're on top of one another, and then it's parallel to that other remaining plane. But in each of these systems, there is no one place where they are simultaneously satisfied. So these are examples of our inconsistent systems. Inconsistent, and then what we kind of think about in terms of solutions is that there's no solution. Or no one solution, I should say. All right. And then finally, we can have the experience where kind of the planes intersect. This first one we have this common line of intersection, and in the second one we have a line as well, but now we have like 2 planes being the same, and then this last one is actually all 3 planes are on top of one another, so we have an entire plane of points. But each of these would be examples of dependent systems. Okay, and here we would say that there are infinitely many solutions. Okay, so just something to bear in mind as you go forward. We still have the same 3 general buckets of types of answers, but what they look like is vastly different. Okay, also so that's from a graphical perspective. So didn't change, but it changed. And then with algebra, we actually can't use the elimination method, only because it gets a little wonky to work with, and so what we're going to resort to is just using substitution method. I warn you, it can get a little tedious, and I just ask that you stick with it as best as you can. Okay, so here when we solve this system, we're only going to use the substitution method. So I'm going to number my equations just for ease of me, and I'm going to say in the first equation I'm going to isolate y. So I'm going to move y to the other side, move 7 to the other, and I'm going to say that y is equal to 2x plus 5z plus 7. Okay, and then I'm going to take that and substitute that into 2. Okay, where I have x plus 4, and then instead of y I'm going to write 2x plus 5z plus 7, and then minus 2z is equal to 1. And so now simplifying, I get x plus 8x plus 20z plus 28 minus 2z is equal to 1. Okay, and if I simplify this, I get 9x plus 18z is equal to minus 27. Divide everything. I guess I'm going to solve for x, and so then here I get x is equal to, let's see, move the 18 over, divide by 9, I get minus 2z minus 3. So that actually works out quite nicely. While I'm at it, I'm also going to simplify what I got for y. So y would equal negative 2, or 2 times minus 2z minus 3 plus 5z plus 7, and simplifying that even further, let's see, so I'd have minus 4, so I just get z, and then this would be minus 6 plus 1, there we go. Alright, and so now I'm going to take both of these results and substitute them into equation 3. I cannot reuse equations. That's one kind of like hard rule that I cannot use, is reusing any single equation. So in equation 3 now I know that x can be represented as 2z minus 3, and then y is going to be z plus 1, and then I have plus z is equal to minus 7. Okay, simplifying, minus 6z minus 9 plus 2z plus 2 plus z is equal to minus 7. And so here I get what? Let's see, minus 3z minus 7 is equal to minus 7. Z is equal to 0. So then that means that y is equal to 1, and that x is equal to minus 3. Okay, so then I have the solution set is, and then I'm going to list this in ascending alphabetical order, so negative 3, 1, 0. Okay, now here I should check my answer, but I will tell you it does check. You should show that work just to make sure that you have the right answer, because some of them can get a little bit wonky. Right? But so I want you to kind of go through this and say, what was the process that we used? Okay. Effectively, it was repeated substitution, where we cannot reuse any equation, but see if you can represent this in maybe 6 steps. So if you were to identify some steps here, what are they? And I guess the 6th one is always remember to check your answer. But see if you can develop a little systematic approach for each of these, and then we'll make sure to move on and talk and get some more practice with these systems of 3 linear equations and 3 unknowns.